Hey everyone, welcome to episode 4 on our Linux series. So in this episode, we are going to talk about the Linux kernel. In this episode, we will be briefly discussing about the Linux kernel architecture, how the Linux kernel is being made, and what are the components. We will discuss about few of the important components of Linux kernel. Post that, we will understand about the main functionalities of Linux kernel. Finally, we will discuss about some of the systemd features and some of the other init processes which are available or pre-existed before systemd. And finally, we will see an illustration on some of the common operations we can do via systemd. So without further delay, let's jump into the architecture. So when it comes to understanding the Linux system architecture or GNU system architecture, as you know, Linux as an operating system is based upon GNU and some of the components taken from GNU along with further developments which has been done by developers around the world. So the architecture or the system architecture consists of three major parts. First is being or known as your front end or your user space. Second is known as your kernel space or your system call interface, where exactly the actually magic happens. Finally, is known as your hardware layer, where exactly your hardware sits. And let's understand or deep dive about each and every phase of the architecture. As I mentioned, as the first phase or the user space, this is the area where all your applications processes run, like such as running any games, or if you want to write any code, or if you want to execute any program, or let's say any application which you want to run, it can sit in this particular space. These applications can be your Google Chrome, whether you want to run your VS Code, you want to run your Slack, whether you want to run any of the game software. This is where all your application will be lying or sitting, which will be again communicating with the GNU C library, or in short, we call it as zlibc. So what is the work of this glibc is that it offers a standard functions, or it provides a suite of code for the tasks which is likely to give any input or output for the memory management, and it acts as an intermediary between your application, all your system calls. So any system calls you are trying to make to your kernel or to your memory from your application is passes through via these libraries, and these libraries comes along with your operating system, and that sits in your user space. And very important about this whole GNU or Linux system architecture is that it is a free and open source operating system which combines your Linux kernel code along with your GNU tools, which comes from the open source projects. And it again works as a very reliable, secure, and versatile across all the hardware platforms, and it can be multiple way, right? The second component of the architecture is your kernel space. So in this space, again, you will have three components. One is your system call interface. Second is your main kernel software. Finally, your dependent kernel codes, which is responsible for doing further functionalities of your user inputs. So in this area, all the kernel or all the functionalities of the kernel is being done. All the core functions as well as interaction with your hardware is being done. So how it is being done, or what are these things are being done? So kernel is responsible for three major work. One is your memory management. Second is your process management. Third is your file system management, and it works as a bridge between your user applications, and the kernel will translate all the applications request into actions which kernel can execute, like reading your files, accessing hardware, how much memory the application will be requiring. All this thing will be done in this particular space. So when it comes to understanding a high level view of what exactly is the memory management. So memory management is nothing but the allocation or optimizing your memory resources, ensuring all your application gets the enough memory to operate. For example, when you buy a laptop or computer, it might be coming with 8 GB RAM, 16 GB RAM, or 32 GB RAM. So kernel ensures each applications or all the applications which are running are getting enough memory to run, and it ensures from all your total memory allocating enough memory for each application to run smoothly. That is the core job of your kernel or the system calls which is happening within your kernel space. Second is your process and thread management. So process you can consider as a independent program or thread which works along with your server that will work together to get your work done efficiently, right? So what is it? What are the different kind of processes? What is thread? We will be discussing later part of the course. But for a high level overview, you can consider processes are independent programs, and threads can be your worker within them, which work together to get your things done efficiently. Next thing is your file system management. From again high level overview, file system you can consider as your how your computer storage works, or it is a fundamental or a way of managing your storage efficiently. How your data is saved into your storage devices and how it is being accessed from your storage devices. File system ensures that how it will be done, file system, how it will be done, your kernel or your kernel space we will be deciding. So that these are the three main functionalities of your kernel. Now at the lower level, there will be your hardware platform. Hardware platform is nothing but your physical foundation of your computer, which can consist of your CPU, memory, storage, and other input and output devices, which is essential for running your overall computer or server. So this makes the whole architecture of your Linux, and it can be divided into three parts. Now coming to how exactly your system call or user call from an application, how it works in the background. So it can be understood from a simple analogy, or you can consider as a three-way communication. The first way will be your user applications and your system libraries, which gives call to your system call interface, which sits in the middle layer. And your system call interface gives all the information to your kernel space, which again does the further process management, memory management, device management, and file system management, which again does the communication to your hardware layer, and hardware layer does all the uplifting under the hood. So that is how a user interaction within your background works in the architecture layer. With that, the last segment is your startup alternatives or other init applications or services available. Few of them are like SysVinit, which was a very old method of initialization. And in that, the way of working was executing all the things or processes in a serial, and it was divided into series which happened in a sequential way. And just consider it as a very old method of managing your software packages or processes, which was later again evolved into further service called as Upstart, where which was developed by Ubuntu and was first launched in 2006. And it was first adopted by Fedora 9 in 2008 and RHEL 6 and its clones. The latest initialization process is known as your systemd, which was adopted by Fedora first in 2011 and by RHEL 7 and SUSE. And it replaced all the init softwares like Upstart, Ubuntu 16.04 version. And in all the common Linux distribution which you see today are using systemd. And it is being a very important function in your whole operating system. We use it for multiple operation. Why it is used? Because as simple as that, it is faster than all the other initialization methods like Upstart and SysVinit. So some of the common commands or operations which we do is like this. We can do sudo systemctl start, stop, or restart for any of the service. How it works, we will see it in our exercises. You can use systemctl enable, disable, followed by the service name for enabling or disabling a system service for starting up at a system boot. You can use some command like sudo systemctl starters followed by the service for checking the startup of the service. These are some of the common used usage of systemd. How it works, how it can be used, we will see in our exercises. So yeah, that's it for today. I hope you like it. If you have any doubts, please put down your doubts in the comments or use the Discord community for asking any doubts. With that, thanks for watching. See you next video.